Hi everyone, welcome back to LangGraph series. This is lecture number 2. In the previous lecture, we have seen the simple LLM workflow. In this video, we are going to cover three workflows. One is sentiment review reply workflow, another is simple RAG agent workflow, and the last one is X post generator workflow with the help of LangGraph. So without wasting so much time, let's get started. I'm gonna open this sentiment review reply workflow. So here what we want to build is, so basically we will have some kind of sentiment, maybe positive sentiment or negative sentiment. Now we want to integrate LLM to decide whether the sentiment is positive or negative. And this particular, once classification is done, then what we want to do, let's suppose if the sentiment is positive, then we will generate a positive note for the customer, or thank you note for the customer. But let's suppose if the review or sentiment is not positive or it's a negative, so in that case we are going to generate a maybe empathy, or something which can feel good to the customer. Now where this kind of workflow can be helpful, so this kind of workflow can be helpful, maybe let's suppose if you are building a running a website where customers are buying something, and you want automatically reply to their maybe reviews, for example on Amazon. So over there you can deploy this kind of workflow where automatically whenever a comment will come or a review will come, so this workflow will be activated. It will read the review, and then based upon positiveness or negativeness, it will reply accordingly. Okay, so let's build this quickly. So I have already prepared this script, so I'm gonna simply copy from here and I'm gonna use it over here. So let's import first of all from LangGraph. All these things is required. Okay, this thing we have already imported in the previous session also, so you must know this. Okay, let me select this kernel, and then I'm gonna load my environment variables. Then this grok LLM is also, you are already aware, no need to explain anything over here. And then we have this class called as sentiment schema class. Now what is this sentiment schema class? I will explain you. Let me first copy and paste it over there. So you see, we are going to use a literal class which we have imported over here from typing. Now what this will do, this will basically tell LLM that whatever review will come, you have to generate either a positive sentiment or a negative sentiment. Apart from these two words, I don't want anything, right? So this basically help us to do this. This is a pydantic model, right? You see, this is coming from base model, and base model is coming from pydantic. Now pydantic is the library which will help us to decide the schema or enforce the schema to the LLM. So that is why this is required. Otherwise what will happen if you don't use this or enforce this schema to LLM will be able to provide you the reviews as a positive and negative in a perfect way. But problem will be, sometime what happens, LLM will not be able to give these words alone. It will try to give here is a positive sentiment, here is a negative sentiment, something like that. So trailing and leading parts, we need to remove those kind of things. Extra bluff we don't want. Okay, now let me go here and let me copy this class. Now what is this class? So this is another class, we are calling it as a diagnosis schema class. Again, this is coming from the base model, meaning from pydantic only. Now what this will do, this is going to identify the issue type, tone and urgency of the review. So issue type can be it is related to UX, performance, bug, support, or any other thing. I have just added this many things. It will obviously depends what kind of business you are running, accordingly you can change it. So this is just an example we are talking about here. So that's why I have taken UX, performance, bug, and all those things. Then tone means whether the like it is angry, frustrated, or disappointed, what kind of tone it is. Urgency, low, medium, high. So whether customer want very urgent solution for that or not, we can identify over here with the help of this particular class. So that's why I have added this one. Now the thing is how we are going to enforce this schema to LLM. We do it with the help of something called as structured output. Okay, so this is a method available inside the LLM, or basically provided by LangChain only. You can use this with structured output. Now you see I have loaded my model over here. You see this is my model. Now what I'm saying, my LLM model, I'm binding it with this particular method with structured output, and first of all I'm passing my sentiment schema, which is this schema. So I'm calling this as my model 1, and this is my model 2, structure model 2. So this model is responsible for giving me the diagnosis schema, and this model is responsible for giving me the sentiment schema, right? So this is how you can enforce the schema to LLM. All right, let me run all this thing. Yes, now let's go ahead. Now let me just try this. Okay, I can try it on some of the sentences. So let's say this is my prompt. It was really a bad product, and I'm using the structured model, first one, and I'm saying dot invoke prompt and then getting the sentiment of it. So dot sentiment. When I do this, okay, so I got the response as a negative. It was actually my internet issue, so that's why it took around 13 seconds, but it won't take that much amount of time. Now let's start with this structure model 2, and let's see what is the outcome of this. So I will say dot invoke, and I'm gonna pass the same prompt. Okay, and from here I'm gonna get all the things, this issue type, tone, and urgency. So I can say result equals to this, and then print the result. Okay, so it will be a dictionary basically, which will have all these things, 3 things. Let me run this. So you see we have issue type other, tone disappointed, urgency low. So there is no urgency in that, that's why it is low. Tone is obviously disappointed, and issue type is other, because this is not related to UX, performance, bug, support, so that's why it is saying other. So this is how you can test it. Okay, now let's move forward and bring, now what we have to do. Basically we need now our LangGraph code will start from here. We need a review state. Okay, so I'm gonna take this class review state. Now what this class will have, this class will have 4 things. A review, so whenever a user will give review, that review will come over here. Then we have sentiment, which we have defined over here, so it is a literal positive or a negative. Then we have diagnosis, right? So diagnosis we have done over here. See, diagnosis means issue type, tone, or urgency, so it's a dictionary. And then we have response. So response meaning based upon the sentiment, we are going to respond accordingly. For positive, we are going to do positive response. For negative sentiment, we are going to reply with the some empathy kind of response. So that's why we have this class. Okay, now as you know, we need to define our all the nodes and edges. So nodes, first of all I'm going to define all the nodes. So I have this 3 node. Let me copy all this entire thing in just one go. Okay, so you see, first of all we have this function find sentiment, then we have check sentiment, then we have positive response, and then we have run diagnosis, and then we have a negative response. Now I will come to these functions. Let me first define the path, and then I will come to it accordingly. So let's go here, and let me copy this graph code. All right, let me put it over here. Okay, so you see, let me run this first of all and then I will show you. Okay, so you see this graph. When I have compiled my workflow, I'm getting this graph. So see what I'm trying to achieve. First of all, we are going to find the sentiment of our review. If the sentiment is going to be the positive, we are going to take this particular route. So this is a first time we are creating a conditional edge. So from here you can take a two path, either this path or this path. That's why these dotted lines are there. Okay, so if the response is positive or review is positive, I will take this particular path. I'm going to reply with the positive response, and I will show you this function or this node how we are going to reply this, and then we are going to end this. Okay, there is nothing we need to do. But let's suppose if it is a negative review, then we are going to run a diagnosis on that. Now to run the diagnosis, again I'm going to show you this node how we can do this, and then finally we are going to reply with a negative response, and then we are going to end this. Now let's come and see all these nodes in one go. And by the way, here you see like how I have created my graph. So first of all, we need to add all the nodes which we have in the graph. So we have find sentiment, positive response, run diagnosis, and negative response. Okay, all these nodes we have. And then finally, how I'm adding it, you see I'm saying I'm starting with the start, going to find sentiment, then from find sentiment go to check sentiment. You see, from find sentiment, okay, so find sentiment is the name I'm giving to the node, but the function behind it is the check sentiment. So this is not the joining part, this is just a conditional edge. So from find sentiment I need to go to I can go to positive sentiment, right? So from find sentiment, either I can go to positive sentiment or I can go to a run diagnosis. Okay, so this is the conditional edge we have, conditional edge. So that's why I have written over here add a conditional edge. Now this conditional edge is defined with the help of this particular function called as check sentiment. Whenever we are going to add any conditional edge, it requires condition when I need to go to positive or when I go to run diagnosis. Okay, but after here, like when I am on positive response node, from there I need to end it, or if I am on a run diagnosis node, from there I need to go to negative response, and then from negative response I need to end it. But this part, when I will go to run diagnosis and when I will go to positive response, it is defined over here in this conditional edge. So from find sentiment, this particular function will help me to go either here or here. So this is kind of syntax I am following over here. Okay, now let's look all these functions one by one. So first of all, let's see this find sentiment, right, which is over here, this particular first function, first node. So in find sentiment, we are using this prompt for the following review, find out the sentiment, and from the state we have the review. So from the state we are getting that review and passing us to our structured model, because structured model, remember, that is the model which is responsible for giving us the this sentiment. So that we are getting over here in the sentiment variable. And finally I am saying return the sentiment which we are already having over here, this variable with the updated value. Second node is called as check sentiment. Now this is just a helper function, this is not a node. Okay, you see there is no node called as check sentiment. Why? Because this is just a helper function which will which is helping over here to decide the edge, right, on which edge we have to go. So that's why this function is there, check sentiment. So what we are doing over here, we are checking from the state we are getting the sentiment, and we are checking if it is a positive, then we need to return a positive response. So this is a name of the node. Okay, this is not a string. Yes, we are returning the string, but this string is same as the name of the node. Okay, so positive response is the name of the node which is over here. Okay, if the sentiment is positive, else we are returning, you see, return run diagnosis node. So we are returning this node. Okay, so this is the main function, driving function, which is basically helping us to route which route we have to take. Then we have positive response. So for positive response function or node, we are using this particular prompt, that write a warm thank you message in response to review from the state. First of all, we are getting this review, and then we are combining that review with the this particular prompt. And then yes, we are simply saying model.invoke, and then we are passing prompt. Here you see we are using model, and we are not using, you know, structured model, because we need a response that can be we can get it with respect to normal LLM call also. And then we are finally returning that response inside a response which we are already having over here. You see, this is our response variable. So we are updating that response variable and returning it. Then we have run diagnosis. So we are again with the help of this prompt, we are going to diagnose that. And for that, remember, we already have the structured model 2, which is going to do the diagnosis and give us, you know, urgency, tone type, and all those things. So we are having the response, and you remember response is nothing but it's a you know, diagnosis is going to be a dictionary, right? So that diagnosis, what we are doing, we are saying response dot dump model dump, because it's a dictionary. So we need inside the diagnosis, it will come as a dictionary when you say dot model dump. Okay, so that's why we are using this. So this is for run diagnosis. And for negative response, again, from the diagnosis, we are first of all, from the state, we are getting the value of diagnosis, and inside this prompt we are sending the, you know, diagnosis of issue type, diagnosis of tone, and then diagnosis of urgency, and then we are saying write an empathic helpful resolution message. So all the things we are getting, and then finally we are generating a response from the model, and we are updating the response variable of the, you know, state, and then we are returning it. So this is how it will look like. Okay, now let's test this particular workflow. So first of all, let's take this example where we will have, you know, I have been trying to log in for over an hour now, and the app keeps freezing on the authentication screen, blah blah blah. I think it's a mostly it's a negative comment only, or a negative review. So let me run this, and I'm going to do, you know, check my final state. So this is my initial state, I'm passing my review, and then after all the, you know, workflow will be ended, we will be getting the final state, right? So that's why I'm writing final state, and let me print the final state. Let's run this. Okay, so you see I have my final state where this was our review. So review is fine, but let's come to the sentiment. So sentiment, yes, we are able to detect it's a negative sentiment. Diagnosis is issue type is bug, tone is frustrated, urgency is high, and then finally our LLM has generated a response for that, and it say, hi there, I'm really sorry you are running into this issue, and I completely understand how frustrating it can be, especially when it's happening right now. Let's get this sorted and all those things. So this is kind of empathy message is being generated by the LLM, right? Now this, when, you know, customer is going to read this kind of, you know, message, it will feel, you know, that somebody, like if the customer has bought something, so, you know, they are caring, basically owner is caring for us. It's not like they have just, you know, given us the thing and then they don't bother about it. Okay, so that's why it looks more empathic, and then, you know, maybe customer will repeat from your website. So, and also, let's suppose if you want to see the final state and just, you know, this thing final reply and not hold the thing, so you can say this. Let me just go over here and check the value, a response, right? So we are using response, so you will say final state dot response. Okay, let's run this. Okay, it's you will say this, it's a dictionary. So either you can get grab in this way, or you can say dot response. So see, this is how you can grab the final response, right? Now let's test this one. This time I'm taking a positive example. The new app update is fantastic. The app runs so much smoother now, and I love the feature you have added. Great job, right? And let's directly say final state equals to this, and print final state of a response. Okay, let's run this. Alright, so you see, hi there, thank you so much for your wonderful feedback. We are thrilled to hear that the new update is running smoother and all those things. See, so this is the okay. Now you see, warm regards, your team. This kind of things are coming, so you can refine your prompt once again, so that this will go, and it will look good to your customer. Cool. Now let's come to the next workflow, which we have something called as simple RAG agent. Now how RAG works, right? It's a basically retrieval augmented generation. We take some bunch of documents, we do like divide it, chunk it, and then finally we create the embedding, we store it into the vector database, then we tied it with the LLM. Whenever user query will come, we do the searching, and then those question along with those documents we send to the LLM to get the final answer. I'm not gonna go into the depth of RAG because you can find much tutorial, but let's directly cover how we can create a RAG based agent, where we will have our main tool, but RAG we are going to attach as a tool, okay, inside a workflow. So for that, again, I'm gonna import these things which are already we are doing it. So let me do this. Now I'm using Azure OpenAI embedding. So when I was created, I was looking for multiple options. I will show you one more option. You can use any function from Google, Azure, or anything for creating the embedding of your model. Earlier I used Azure OpenAI embeddings, but this time maybe I can use something else. So let me see. I will go here and copy this. Okay, so here this is the function get Azure embedding model. Now in order to get the Azure embedding, you need Azure deployment, Azure endpoint, API key, and API version. I don't have this right now, so this is just a like for your knowledge, but let me take another example. So what I can do, I can go here. I have already this particular function, Google generative AI embeddings. So I'm gonna use this, okay, instead of that. Let me put it over here. So we will use this Google generative AI embedding, and we need to install this particular library, LangChain Google Gen AI. So I will go to terminal and I will say uv add this thing. Till the time that is happening, this is the function I have written. Okay, this is still running, so that's why the error will come. So this is the function get Google Gemini embedding model, and we are using this particular class Google generative embedding, and we are using model Gemini embedding 001. This is the embedding model we are using. Now if you are on you want to use Azure OpenAI embedding, feel free to use it, but you need to deploy your model first on the Azure. Okay, now let me run this, and then this. Cool. Now this thing you are already aware, just a simple LLM setup. Okay, So this thing langchain.schema also need to be installed properly. So I will say uv add, or let me see the proper value because this was giving some error. Let me see what is the langchain core community open. Okay, I will say langchain core. Okay, let me see if this is there or not. Okay, langchain core is there. Langchain community, let's add this. The document is from there. Okay, so I checked this particular error. This is the langchain.schema is in the from the previous one. We need to import it like this, langchain core.documents. Okay, so that's why this is required, langchain core. Okay, let me remove this and okay, langchain underscore dot core, right? And also human message is not available inside this schema. Okay, and if you see human message, so for human message we need to import something else, but either way I'm gonna use this. And again, obviously this human message, as we know, it is not available inside the langchain core. It is available in different package, but for document I need that. So let me do this thing. First of all, I am gonna do say this. This looks good. Now let's come over here. And you see this document, I have already done it. The schema will fail, so that's why this is required. And then I'm gonna import these things over here, over here. And you see this chroma is also not available inside the langchain community. This was the previous code, so I have written new code. Chroma is available inside the langchain community.vector store. Okay, so let me copy these two things from here and put it over here. Okay. Now again, I need to add this langchain community. All right. Till the time this is downloading, so what I'm doing, I'm importing this get Azure embedding model function, but I'm not gonna use this for this time being because I don't have the Azure credential setup. I will be using this Google generative AI, so I will need that. Okay, so let me load this instead of this one. All right, and then so this is my documents. I'm taking very simple example. Okay, so I have some gym related document, and from this document I want to create a rag on top of it. Okay, so you see the document is related to peak performance gym, and we have some metadata as sources. Okay, now in further lectures I'm going to show you how you can take some data from the scratch, maybe from the PDF. And when I say PDF, it's not going to be the small PDF. I will take GBs of PDF, and I will show you how you can create a proper embedding with respect to roles and all those things, and then we will see this into the project. But right now just I'm taking an example of workflow, rag agent workflow, so that's why I'm taking a very simple basic document. Okay, now let's wait to finish this and then I will run this particular code. Okay, so this got run. Now I can run this thing. So let me run this quickly, and let me check this. Pip install ChromaDB. So I need to add this ChromaDB. uv add ChromaDB. You can take any vector database. I'm just taking an example of ChromaDB. So let's wait. Once this will be finished, I will run it, but I will have further code. So let me put it over here. And once we have our vector database ready, we can just create a retriever on top of it, and then we can create this kind of tool. Let me show you what this kind of tool it is. Okay, let's run this. Error should be gone now. Okay, now the error is gone. Next is we need to create a tool. Two tools basically we will create. One is a retriever tool. So retriever tool basically is a tool which is going to retrieve the documents from the ChromaDB. So for that I am using this predefined function called as create retriever tool. Earlier it was inside this langchain tools dot retriever, but now they have changed it. So we need to use something this one from langchain core dot tools dot retriever. We need to this thing. So I will go here and then import this. Okay. So create retriever tool is a by default function provided by LangChain. Okay, so they have created this in which we can pass our retriever. So retriever object we have already created over here with the help of ChromaDB object. So we are saying db.asRetriever, and search type we are keeping it as MMR. Search keyword arguments we are passing only 3. So retriever tool we are passing, and then we are passing some prompt so that they are basically using LLMs behind the scene of this function, so they will able to fetch the proper documents. So we have this retriever tool, and then we have something called as off topic tool, and this is a simple function. Now in order to make this function as a tool, we have imported this langchain core.tools import tool. So this is a decorator with the help of which you can create any function as a tool. So again, this is we are writing some Python hints, where this will basically tell the LLM if the question is not related to peak performance gym history, then it will simply return forbidden, do not respond to the user. Simple. Okay, now LLM will able to understand based upon this Python strings we are writing. Okay, so this is very important whenever we are defining a function. So the function basically this function strings are required. Okay, so with the help of that only LLM will be able to understand. So we have these tools, a retriever tool and then off topic tool. We are combining these tools inside a single list. Okay, alright, now we have all the tools ready. So now I can simply go and start writing my LangGraph code. Okay, so let me copy this, put it over here, and you see this time I am importing another extra function called as add messages. Now what is this add messages? So see, whenever we interact with any of our maybe bot, let's suppose ChatGPT. So ChatGPT, you wanted to remember the previous conversation basically, right? So add messages is a kind of function provided by LangGraph. This will basically help us to remember the previous conversation or add the messages on top of it. So it's a list, and we also call it as a reducers. Okay, inside the LangGraph. So this is I'm taking a state variable called as messages, which is going to have this base messages. Now base messages meaning it can be AI message or human message, and I'm giving comma and I'm saying add messages. So basically it will act as a reducer. So whenever a previous message will come, it will not replace it, instead it will keep appending the previous messages inside this list. Okay, so that's why add messages is required. Then let me import some other stuff. So you see human messages inside the langchain core dot messages. Okay, so let's import this thing, and then these are the two nodes. Let me simply copy it, and I will explain you further once I will build the graph. Okay, right now I will run this. Now let me write the code for graph. We'll go here, and now you see I'm importing the start and there is something called as tool node. Okay, now what tool node is required, so I'm gonna explain you this in a second. Let me first show you the compiled graph, how it looks like. Okay, so I will run this particular thing. Now you see I have a start node, then I have something called as agent, and then I have tools. Now you see from agent I can go to either end or I can go to tools. There is a two thing. Okay, now if I go to tools, from tools I am coming back to the agent, and then I'm finally I'm going to go to end only. So this kind of pattern, this kind of looping, we call it as a react agent. So first of all we are going to do reasoning, and then we are going to take action. So this is a react agent pattern. Now in order to build this kind of pattern, you can build this in LangGraph in a multiple way. Right now I'm showing you one way. So this agent, remember we have written one node over here for this agent. Now what this agent is doing, it is simply from the state it is getting the message, then it is calling the grok LLM, and this model is bind with some of the tools. You see this model is bind with some of the tools, so that LLM will be able to know which tool I have to invoke. And remember we have only two tools, off topic tool and rag tool. You see over here we have defined this retriever tool and off topic tool. Retriever tool, whenever we are going to talk about peak performance gym, this tool will be called, and if we are not going to talk about peak performance gym, off topic tool will be called. Okay, so that's why we have this tool. And coming back to this code, yeah, so this model is simply going to invoke with the messages, and we are going to return the response inside the messages. Okay, in the same messages we will append it. So that's why this response is available inside the list. Okay, now so how this kind of looping is being made. Okay, so in the LangGraph we have imported something called as this tool node. Okay, so you see, if you see this particular code, we are first of all having this workflow where we are defining it. We are adding a node called as agent, and then with the help of tool node, whatever tools we have defined. So remember tool is our list. If you go over here, this is our list. We have two tools. Now we are passing these tools inside a tool node. So this is a by default node coming from the LangGraph only. See, we have imported over here. So this will convert our tools into a tool node, and then we are adding that node also inside our workflow. That's why we have something called as tools. You see, these are tools. Okay, and then if you see, we are starting from our graph from start, going to the agent. Then we have something called as conditional edge. From agent, this function should continue will help us to know where I need to go. So from agent I can go to tools, and then from tools again I need to come back to agent, otherwise I need to end it. Now how this thing will happen, I need to go from agent to tool or from agent to end. This is going to help happen with the help of this function called as should continue. Now when I go to should continue, you see in should continue I'm just grabbing all the messages, and then I'm grabbing last message by saying -1 from the list, and then I'm saying if last message dot tool calls. So in the last message, is there any tool call is happening or not? Now tool call is happen based upon this model, right? Because model know if the question will come related to peak performance, they need to use the retrieve tool, and if it is not related to peak performance gym, it will use the off topic tool. So in the last message you will have the traces of tool calls. Basis on that you will say if the traces of tool calls is available, you need to go to the tool node, else you will go to end node, right? So this is how this graph is created, and this is called as react agent pattern, right? Now let's invoke this graph and see what kind of answers we are getting. Okay, So I'm gonna use this, and let's print the result. So I'm saying, how will the weather be tomorrow? So this is the messages, human message, how will be the weather tomorrow? And you see the entire trace, okay? Then you have the AI message is nothing. And when you go over here in the last, okay, you see there is something called as name equal to off topic, meaning this tool is getting called. Why? Because this question was not related to peak performance gym. That's why. So you see tool message content forbidden, do not respond to the user. Remember, inside that tool we have written forbidden, do not reply to the user whenever we are going to get off topic response, and that's why we have this thing. Okay, so this is how our final result is, right? At the end when you go, you see all the tokens and everything, you will be able to see it properly. Okay, cool. Now let's take one more example, and this time I will ask the question related to peak performance gym only, and let's print the answer. I'm asking who is the owner and what are the timings. Okay, let's run this, and you see message, human message was this, AI message was this, that they need to call this tool. Okay, so first time AI will LLM will be able to understand, okay, for answer this question I need to call the tool. So let me show you. If I go over here, where tool traces will be shown, let me show you. You see tool calls equal to name retriever tool. Okay, and this query was passed inside that tool, right? Then you have this tool message. So from tool message, whatever your retriever will go and find the documents, that documents will come. So see, this is the content. Peak performance gym is open Monday through Friday, this all these documents were getting fetched. Member with premium access performance gym was found in this all this thing, and then this will be sent to back again to LLM, and then finally you will have your final AI message. So this is the content owner, and you will say peak performance gym was founded in 2015 by a former Olympic athlete, and blah blah blah, whatever the thing is, like the final answer. Let's suppose if you only want to see the final answer, right? So you will say result dot content. Okay, let's try this. Let me run it. Okay, it was dict actually, so you need to say in this way. You will have the result, and then you will say result of messages. Okay, messages dot content. List objects has not. Okay, let me see how we can grab the final answer. So for that I have also written some code. Oh yes, -1 dot content. So I need to see the last content, right? Because if I show you, you see we have the messages, then AI message, tool message, AI message. So I need to see the last one, AI message. So I will say this result of messages of -1, this one dot content. Okay, Now this is our final answer. You see, peak performance gym owner is this, operating hours is this, and the gym remains closed on this. So this is our final answer, right? So I hope you are able to understand how this React agent works, and we have seen the simple RAG agent tool, right? Now let's come to the third one, which is called as X post generator. We are trying to generate a Twitter post basically, and here the aim is like, let's suppose whenever a topic will come, we will generate the tweet, but we will use LLM as a judge. Let's suppose if the tweet is generated, but we don't like the tweet, then what will happen? We are going to give some feedback, okay, some feedback to the LLM that generated tweet is not good. So what will happen? It will generate the tweet based upon the feedback, and again it will show us. Again, if we like it, we will say okay, but if we don't like it, we will say you need to regenerate it, okay? But here no human will come into the picture. We will do this entire thing based upon LLM only, okay? So let's see this how we can do this. I'm gonna open this, and again this things is some imports are required, so let me do this, all the import. We are going to use this Grok LLM and all these things, you are already aware of it. Yeah, and this time we are going to use 3 different LLMs, but actually I'm using the same LLM, but in real world scenario what will happen? See, if you are having one LLM for generating the tweet, you should use different LLM for doing the critique, so that you can get a different angle also. But I'm using the same LLM, Grok LLM only, for generating the tweet, evaluating the tweet, and optimizing the tweet as well. Okay, ideally you should use 3 different or at least 2 different LLMs, but I'm doing the same thing. Now let me copy this Pydantic schema class and explain you what is this. So first of all, I'm using this class called as tweet evaluation. Now once again we will have generated our tweet, we need to evaluate that tweet, right? So in order to evaluate that tweet, I'm using this tweet evaluation. So we are going to give this schema to LLM, and what LLM will do, LLM will give us the evaluation as well as feedback. Now evaluation can be of 3 types: approved or needs improvement. So the 2 types only, okay? Either LLM will say approved or it will say needs improvement, and in the feedback it will write the feedback, okay, what kind of feedback they want. Let's suppose if it is approved, then there is no feedback, or you can say it will be feedback but it will be good. But if it is needs improvement, then what kind of improvement that will be provided inside the feedback. So these 2 fields will be given by the LLM, okay? Now I'm gonna create a structured LLM, because with the help of structured LLM only we can do this. So I'm saying evaluator LLM I'm using, and I'm binding it with structured output, this particular method, and I'm passing my class. So this is going, I'm storing it inside a variable called as structured evaluator LLM, okay? Now I'm gonna create my tweet state, okay? So this is my tweet state. This should be class. Now in tweet state, what are the things what are the variables I'm keeping? So first of all, a topic will be given by the user, so topic will come. Then based upon that topic, I will generate a tweet. Then we will have evaluation, approved or needs improvement. The feedback is also there. Then I want to count the iteration, how many number of iteration of the feedback we have given. Why this iteration is required? See, because we are using LLM as a judge over here. Now you see, you generated a tweet, LLM will say needs improvement, you go for the first iteration. Once again you generated a tweet, Again LLM will say needs improvement. You once again go to iteration, and since it's a LLM, it's a non-deterministic in nature. This loop will go to infinite. That's why we need a iteration. Let's suppose if 3 iteration will be done, we don't want to regenerate the tweet again and again. So at that time we will break it. So that's why I need this iteration variable. Then we have something called as max iteration. So we count, if iteration will become 3, then the max iteration number will become the same. Like we will set this max iteration by us. So if iteration will become same as max iteration, we are going to break this loop. Okay, we don't again need to generate the tweet. Then we have something called as tweet history. Now what is this tweet history? Tweet history is, again, we are using something called as operator.add. Now operator.add, remember we earlier we were using here, we were using something called as this add messages, right? Let me show you. In the state variable, okay, here it is not here. We were using add messages. So add messages and this thing operator.add, they mostly work in a similar fashion. They both are reducers. So in tweet history, it is going to be a list where we will have the first version of tweet, second version of tweet, third version of tweet, and so on and so forth. With the help of this operator.add, we can keep appending the history of the tweets in this variable, and same goes with feedback history, right? So that's why I'm using operator.add. Okay, it is similar as your reducer function add messages. Now let's come over here and let's define our first node called as generate tweet. Okay, let me copy this, come over here and paste this. Now let me explain you this function right now only. So we have this generate tweet where I'm using this system message, and this is our human message. Write a short, original and hilarious tweet on the given topic. The topic, we are going to grab it from the state variable, and then this entire a prompt or message, I'm going to pass it to the LLM, which is our generator LLM, and it is going to give us the response of the tweet. So that response we will save it as a tweet, and then tweet history, again we are passing a list of response. So this is a first tweet history we have generated, right? So this is our generate tweet function. Next we have our evaluate tweet function. So let me copy this also. Okay, now in the evaluate tweet, again this is also going to take a state as an input, and then what we are doing, we are creating this message or prompt, we are grabbing the tweet from the state, and then you see what I'm saying, we need to evaluate it, right? So system messages, you are a ruthless, no laugh given Twitter critique. You evaluate tweet based upon humor, originality, virality and tweet format, and then we are passing our some of the criteria. Use this criteria to evaluate the tweet. Originality is the fresh or have you seen it 100 times before. Auto reject if all these are our criteria, right? Auto reject if it is written in a question answer format, exceed 280 characters, and so on and so forth. So this is our message, and then again we are using the structured evaluator LLM model this time, and we are invoking that model, and finally we will have the response. So in the evaluation, we are going to say response dot evaluation, because remember evaluation will going to give us either approved or needs improvement. So we need dot evaluation from the response, and then in the feedback we are going to put dot feedback, and in the feedback history again we are passing the same thing in the list format. So this is our evaluate tweet function, or you can say node. And then finally we will have something called as optimize tweet. So let's suppose if needs improvement will come, then we need to optimize that tweet, right? So let me copy this function also and go over here. Now in order to optimize the tweet, we need to first of all get the tweet, right? So from here we are getting the topic from the state, we are also getting the tweet, original tweet, and we are also getting the feedback. And then with the help of this particular prompt, we are saying you need to rewrite it as a short viral worthy tweet, avoid Q&A style, and stay under 280 characters. Simple. And then we are using our optimizer LLM to invoke it. Now we are using, internally all the Grok LLM, which is GPT-OS 20 billion model, but I recommend you change it for each and every node basically. And you see what we are doing over here. After getting the response, generating the response, or you can say a new tweet, we are also from the iteration, state iteration, we are adding a +1 value so that we can understand, okay, this is a first iteration or a second iteration. And then we are returning all the things inside a state variables. Tweet inside the response will be under the tweet, iteration will be under iteration, and then this response inside the list, we are going to append it inside a tweet history, right? And then we have something called as route evaluation. So this is not a node, but this is just a helper function which will basically going to help us in which direction we need to move once we are on a after generate node. So once we have generated the node, this function will help us to route where we need to go. So we are going to check the evaluation from the state. If it is approved, or if the iteration is greater than equal to max iteration, we will say approved. Okay, else we are going to return needs improvement. So we will jump to needs improvement node. Okay, now let's combine all this together to our state graph, and I will show you how it will look like. So let me copy this. Let's come here, and I'm gonna run this to show you. Name tweet state is not defined. Okay, I need to run all of them. So let me run each and every cell. Okay, so you see this is how our graph looks like. We have a start node, generate node. After generate node, we will go to evaluate node, and after evaluate node, we either we can go to approved and then end it, or if it is a needs improvement, then we need to go to optimize node. Now from optimize node, we are going to regenerate the tweet, and once again we will come back to evaluate node. Once again LLM will evaluate it. If it is approved, it will end it. If it is a need improvement, once again we will optimize it, and this loop will keep continuing. So here also you see we are creating kind of a loop. Okay, and this, when this loop will break, either if it is a approved or if we have reached to the max iteration, we will break this loop. So the same code we have written inside over here, you see inside the optimized tweet, right? If the here in the route evaluation, if it is a approved or if it is a max iteration, we are going to say approved, or we are going to say needs improvement, right? So that is our node. Now let's test this node and see what we get. Okay, so let me copy this and come here, paste it over here. Okay, so this is my initial state. Let's give the topic as data science and AI. Let's say this is our tweet topic. I want to keep so I will start with the iteration as 1, so I will pass iteration as 1, and max iteration, let's say I won't keep 4, I will say 3. Okay, so after 3 iteration, if it is still generating the tweet, we will break the loop. It might happen that in first iteration or second iteration, LLM will say okay, it is approved. Okay, and then finally we will have the result, and we can see that result of messages of -1 dot content. Okay, So let me run each and every segment of it. Okay, we are getting the key error, so let me remove the messages because obviously we haven't have added the messages inside our state variable. If you see our state variable, it has topic, tweet and all those things. So I will simply go and see the final result only. Okay, let me run this. So you see we have this topic, generated tweet was this, evaluation for the first time only, it says approved with this feedback. So iteration was 1, max iteration was 3, this was the tweet history and this is the feedback history. So you see in the first go only this was passed, right? So this is our final result. Now if you want to grab something from this particular dictionary, for example your generated tweet, final tweet, control C, so you can say result of tweet, you can grab your final tweet, right? This is your final tweet. And yeah, if you want to iterate through each of your tweet history, because it's a list, you can iterate in this way, right? Right now we have only one tweet history. Now let's take a different topic. Let's say I will give let's say AI in aerospace. Okay, let's say this is my tweet topic. Let's run this. Okay, again it is saying approved. Let me take some different example. I will put some gibberish thing, okay, TTSH something, to just take an example, right? Now see, this is taking much time, so it might be iterating again and again. So let's see. Okay, so you see okay, this is also got approved. Okay, I'm not getting any case where it will say it will take more than one iteration basically. So let's take some more gibberish thing. I just want to show you it will take some more iteration also. Every time it is approving. Okay, let me see if I can take something different. Hula Balu. Okay, it's not taking, guys, but the thing is it will take for some, it is approving in the first iteration itself, it is saying approved, but let's read the feedback. The tweet cleverly this thing, so all these things are basically unique maybe, so that's why it is saying like it is approving in the first half only. But let's take an example of maybe very common topic, let's say heart. Okay, heart, let me just put this heart. Okay, this is also got approved. Anyways, I will keep this up to you. You can choose any topic where it will try to basically generate a tweet and it will iterate also. This works, I have tested it worked on iteration as well. I'm not able to show you example, but you can test it from your end. Okay, so we can conclude our this video over here only. In the next video I will show you some more workflow. We will build some more interesting agents, and once we will create our base till some certain amount of time, I will also show you how we can introduce human in the loop. Right now you see we are doing this thing LLM as a judge, right? LLM is evaluating and LLM is optimizing this tweet, but we can for evaluation purpose we can put a human, and that comes as a human in the loop concept inside the LangGraph. So I will try to cover all those things in upcoming videos. Okay, see you next time.